Okay, question 1 for HL and SL. This is a fairly straightforward question, or at least it's supposed to be if you studied. But we have Sarah goes into a coffee shop and she has to wait for her coffee. Now, how long she waits depends on how many customers there are in front of her also waiting. So if there's 3 customers, she has to wait 6 minutes. If there's 9, 10 minutes, 11, 12 minutes, this is what she experienced on 5 different days. Anyway, the relationship can be modeled by the regression line y equals ax plus b. Question A, I. Find the values of A and B and write for II, write down the value of or is the correlation, Pearson's product moment correlation coefficient. Okay, let's do both of those. They are 2 nice, easy questions. Okay, take out our calculator. In this, I'm going to write, well, let's call this X and let's call this Y. Then here I'm going to do 3, 9, 11, 10, 5. 3, 9, 10. Sorry, 3, 9, 11, 10, 5. And here, these have to match up, guys, of course. 6, 10, 12, 11, 6. Then I go menu, statistics, stat calculations, linear regression, mx plus b. My x list is my x, my y list is my y. The rest of this is fine. Results in D, fine. Press OK, and this gives me there's my R value. And okay, it's AX plus B. In this, it's MX plus B, so your M is your A, and your B is your B. Okay, so write the values of A and B. Let's do that first. So A is 0.805085, so A equals 0.805. What did I say? 805.085. And B equals, there's no working required here, guys. It's just 3 marks for each, for A, B, and R. So B is 2.88136. 2.88136. And then part II, or is equal to, it's right here, 0.977772. 0.977772. Okay, always have questions about 3 significant figures. Guys, put down the 6 significant figures first, and then you can just do approximately equal to 0.805, approximately equal to 2.88, approximately equal to, let's do that properly, approximately equal to 0.978. But leave these, put this number down as well, because even if you mess this up, you probably still get the marks. Okay, part B. Interpret in context the value of A. Okay, so this tells us, as I said at the start, it's how long Sarah has to wait depending on how many customers there are. So A, which is kind of the slope of this line, tells us it's the change in wait time for every X. So when they say in terms of the in context, they mean it is so A is the amount of time in minutes, Sarah has to wait. It's the amount of time in minutes Sarah has to wait per person waiting. So it's the amount of time she has to wait per person already waiting, if that makes sense. So or for every, it's the amount of time she has to wait for every, hang on, let's write that properly, for every for every additional person already waiting, I should have said. For every additional person already waiting. So for every extra person waiting, she has to wait another A minutes, which in this case is 0.805 minutes. Okay, finally, use the result from part AI to estimate Sarah's waiting time. So we have this model now. It is y equals, now look guys, I'm going to go back, don't use the rounded version here, or use the less rounded version. 0.805085. Well, let's do x plus b, which is plus 2.88136. Now, use the result from part AI to estimate Sarah's waiting time. Okay, so sorry, I didn't read this bit. On another day, 7 customers are waiting. So there's no 7 here, but I'm going to use this regression line, and I'm going to sub in 7 for x, because there's x is the number of customers waiting. So if there are 7, it's 0.805085 times 7 plus 2.88136, and that is equal to, let's just move this here. Sorry, let's get rid of this. No, I don't want to save that. 0.805085 times 7 plus 2.88136, 8.51696, 8.51696. So her waiting time is approximately 8.51696 minutes, or 8.52 minutes, if that's what you prefer, or approximately 8.5 minutes. Okay, done. That is question 1 for both HL and SL. I'll see you for question 2.